This is our video on Chapter 36, the average value and the mean value theorem for integrals. So the average value is a fairly straightforward calculation. We have a continuous function on a closed interval AB. Now, if you want to take the average of a list of numbers, what do? You add the numbers up and you divide by the number of numbers that you have. So for example, if I have two test scores, an 80 and a 90, and I want to take the average, I add those two together and I divide by 2, and the average is 85. When you have a continuous function on an interval with infinitely many numbers in it, that doesn't work. So what we do instead is, instead of adding up the numbers, we integrate from a to b of f of x dx. And instead of dividing by the number of numbers we have, we divide by the length of the interval. So this is calculating the average value of a continuous function on a closed interval AB. There are some similarities between taking the average of a list of numbers and some differences. Okay? One similarity is this. If I take the average test value of a class, it is not possible that every single student scored below the average, or it wouldn't be the average. It's also not possible that every single student scores above the average. So that is one similarity. It is not possible that your function is above the average over the whole interval, and it's not possible that your function is below the average for the whole interval, or the average would not be the average. That is one similarity. One difference, though, is that if I'm taking the average of test scores, it is not necessarily true that any student scores the average. So I gave you the example of a student that scores 80, a student that scores 90, the average is 85. Neither student scored 85. That's possible with a finite list of numbers. It is not possible with a continuous function over a closed interval. That is a difference. Here's why. Remember, a continuous function on a closed interval has a max and it has a min. So here we have our min, and let's say that min occurs at C. And then we have our maximum value, and let's say our max value occurs at D. The intermediate value theorem says that on the interval C to D, f takes on every single value between the min and between the max. The average is between the min and the max, or else it wouldn't be the average. The average can't be above the max, and the average can't be below the min. The average is between the min and the max. So the intermediate value theorem says somewhere between C and D, the function takes on the average value. Now, this function apparently takes on the average value in more than one place. It takes it on right here and right here, and that's okay. But the intermediate value theorem just talks about what happens on the function between C and D. And it will be between the min and the max. And since the average is between the min and the max, what theorem 350 tells us is that somewhere between C and D, our function is the average. It doesn't say where, and it doesn't say how many times. I could have drawn this differently, and it could have done this a little bit and then come up here. So it might have taken on the average value more than once. I have not worked through example 349. Example 349 is fairly straightforward, and it is in your notes. So if you have any questions on example 349 after studying your notes, then send me an email.